All right, so class has started. It is 10:10. Good morning, everybody. I hope you guys are doing well. I hope your families are doing well as well. Looks like the rain is coming back, so I hope you guys stay warm and dry. So what we're going to be doing today, so last class we talked about translations, right? We started chapter 4. And so today we're going to take the next step in transformations and with reflections, okay? So it's going to be a little bit more difficult than translations, and it's going to take up my whole class, so I have to get started right away, okay? So to do a little quick review here with translations, we have formulas. Oops, I'm on freeze. Okay, so with translations, we have these formulas that tell us what we're doing. Now remember, composition means 2 or more. That means that we're doing both of these, right, from our original shape. So we're going to take our shape, we're going to move it once, and then we're going to take that and we're going to move it again, okay? So let's go ahead and take a look at this and see what we're going to be doing. So remember here, each of these up here are going to have, right? They're going to have, each are their x and y, right? So what we're doing for this formula is we're taking all of those x and y pairs and we're doing this. That's how the formula reads, right? We're going to take all these x, y pairs, right? That's what this is saying. And we're going to do this formula to it. So now remember, we're doing this without a picture. So remember that the what's going on here is we have x minus 2. That's going to be left 2. And then the y plus 1, that means up 1. Now, if you're having trouble seeing that, just remember you can just quickly graph a coordinate system. Okay, or a Cartesian plane if you're being fancy. And the x is positive to the right, x is negative to the left, y is positive up, and y is negative down. So if you're struggling with trying to figure out, hey, without a picture, how do I know if I'm moving left, right, up, down, or what's going on? You can always just draw a coordinate system here, and that's going to help you figure out what direction we're going in. Okay? So we're going to take, so let's go back to this. We're going to take every point x, y, and we're going to shift it left to up 1. Okay? So I'm just going to be taking my x components here, and I'm going to be plugging them in. So my first point is I'm going to move a 1 time, right? So I'm going to take this a, and the prime means I'm moving it once. So I take my x is 0, so I have 0 minus 2. So that's going to be negative 2. And then I'm going to have 3. I'm going to have 3 plus 1. That's going to be 4. Okay, so again, I'm just taking the x and y in my point, and I'm plugging it into my formula. So I'm going to have b prime. So I take the x in my b, which is 2, and then I'm going to subtract 2. So I get 0. And then I'm going to take my y from my b, and I'm going to plug it in here. So 4 plus 1 is 5. And then my c prime, I'm going to take the x of my c. So 1 minus 2, that's negative 1. And then I'm going to take my 0 plus 1, that's 1. Okay, so there is my first step of my composite. Hey, I'm glad that you're getting caught up. That's really good, and thanks for doing that. Life is hectic and crazy, so I'm glad that you're getting it done. Get it, and this is just a note for everyone. Make sure you guys are getting your homework done. It's 80% of your grade, right? The trimester ends March 12th. That's really close. So if you have missing work, you want to start getting that done. So that you're not like just absolutely overwhelmed at the end, right? Because everyone in here should be able to get a good grade, right? Just by doing that work. And if you guys need help, remember my office hours are in the morning. All you gotta do is show up and I'll help you do your homework. Okay, it's that simple. All right, so our next little bit that we're gonna do here. So if we see here, what are we gonna do? We're gonna go right 1 and we're gonna go down 3. So remember, because we're doing a composition, right? See how it says composition? That means that we go from here to here, and then we're going to go from blue to red to our red, right? So from black, right, from these ones right here, right, we plug that into here. And then what we're going to do now is we're going to take our prime and we're going to plug it into here. Okay, so I'm going to get a double prime. Okay, and that's where I'm going to take a prime and I'm going to plug it in. So my x for my a prime is -2. So -2 plus 1 is -1. The y for my a prime is 4. 4 minus 3 is 1. Okay, so there's my a double prime. Okay, and then I'm going to have b double prime, and thank you for the heads up. I appreciate it. Okay, and remember, all these lessons are always on YouTube, so if you miss it, you can check it out on YouTube, or you can send me an email, and we can figure out a way to communicate and get all that stuff done. So b prime, so I'm going to have 0. 0 plus 1 is 1, and then I'm going to have my y. 5 minus 3 is 2. And then I'm going to have c double prime. I'm going to have -1 plus 1, that's 0. And then I'm going to have 1 minus 3, that's -2. Okay. So this again is my final resting place for my original triangle ABC. I moved it once and then I moved it twice, and that's a composition, right? So you do 2 and they build on each other. All right, how are you guys doing? Do you guys need me to explain anything that I just talked about? Do you guys need me to go over or answer any questions before I move on? We have a lot to talk about today because transformations are difficult without graph paper. Okay. And then remember, guys, you can always ask questions by using chat and turning on your microphone. Okay. I appreciate both of those ways. All right. So what are we doing today? Well, we're going to learn a new type of transformation. We're going to talk about, so it's 4.2 in the book, we're going to talk about reflections. Now, reflections are really easy to do on graph paper, but we don't have graph paper. And so we're going to have to rely a little bit more on algebra, which is always a little bit more difficult because it's less visual. Okay. So in reflections, we're going to have 3 things. We're going to have the pre-image, right? And remember, the pre-image is our original shape. So for example here, the pre-image was triangle ABC. So the pre-image is your original shape, okay? We're going to have the pre-image, and then we're going to have a mirror, and then we're going to have an image. Okay, so those are the 3 parts to a reflection. You have your original, you have a mirror, and then you have your new. Okay. An important note here, for the mirror, we're going to use a dashed line for the mirror. Okay, and that means like this. Okay, so that way, especially if you're just writing with a pencil or one colored pen, that way you know the difference between an axis and the mirror. Okay. So we're going to start by writing down the definition of how a reflection works, and then I'm going to show you an example. Okay, so right now we have 3 pieces, the pre-image, the mirror, and the image, and we're going to use a dashed line for the mirror. Okay, so here is what a reflection is mathematically. The distance, okay, so the distance from the pre-image, okay, so the distance from the pre-image to the mirror, okay, so the distance from the pre-image to the mirror is the same, and I'm going to underline that because that's the most important part of this long sentence. So the distance from the pre-image to the mirror is the same as the distance from the mirror so it's the same as the distance from the mirror to the image. And I'm going to show you an example of this right here because I got myself a little mirror. and we're gonna show you what that looks like. Okay. So to give you an example of what this looks like, I don't want you to copy this down because if we were in class, right, I'd have mirrors for everyone and we'd be able to do this, but we don't. So don't do this part. Just look, just watch, just enjoy, relax a little bit, be like, hey, I don't have to write anything down. Okay, so let's say we have a coordinate plane. Okay, or a Cartesian plane if you're super fancy. And then over here, I'm going to draw a triangle. And I'm going to label it. I'm going to label it A, B, C. Okay, and again, you're not drawing this down, so you're just watching, so I can go at any pace I want. Now, what I have here is I have a mirror, okay? Looks like it's a Lorac mirror that was part of used to be part of a makeup kit that my wife had, right? So let's take a look. So what we're going to do is we're going to show this property, that the distance from the pre-image to the mirror is the same. Now, first I can do this without anything there. So you see my hand, right? So my hand's real, and then you see the image in the mirror, right? So here's my real hand, right? My real hand. Well, it's not really my real hand. You're seeing it through an image, aren't you? Ooh, that just got deep. Okay, inception. So in the mirror, you can see the image of my hand. So my hand is the pre-image, and the image in the mirror is the image. Now, notice, here's my finger, here's the mirror. What happens to my finger as I get closer to the mirror? It's hard to see, but if you see there, do you guys see how my finger is touching my finger? And then as I go away, my finger goes away. Okay? And so that's what we're saying. The distance to the mirror is the same as the distance away from the mirror, right? So if you went up and you kissed the mirror, you're kissing yourself. Ooh, hoo, hoo, hoo. Unless you have one of those creepy mirrors, and then you're kissing the scary, creepy girl with the long hair covering her eyes that is like trying to murder you and your family. Maybe I watched too many scary movies. Okay? So that's what's going on here, right? The closer we get to the mirror, the closer my image gets to the mirror, right? The further I get away from the mirror, the further it gets away. So what I'm going to do here is I'm going to show you a type of reflection. So I'm going to reflect this triangle over the y-axis. And when I do that, notice how C is closer than B, right? You guys see that? So C down here is really close to the mirror. So C is closer in the image. B is further away, so B is further away, and A is the most furthest away, so it's the most. So you guys see how that works? So that's the physics behind it. That's what's going on. So the physics of it, it's the perpendicular distance, and we use perpendicular because it's the shortest distance, right? The perpendicular distance is the same on either side of the mirror. Okay? All right, cool. So that was my little example, right? What I can do from home. All right. So now what we're going to do is we're going to do an example of this. Now, to do this without graph paper, we're going to have to use a visual aid, okay? So, and I'll show you what I mean here. So in our first one, we're going to use a visual aid to help us out, okay? So the problem is going to be, it's going to be given triangle ABC, where, I'm not going to do it that way. Okay, given triangle ABC, A is -3, 2, B is -1, 1, and C is -4, 1. Okay. We're going to reflect triangle ABC over the y-axis. Okay, kind of like what I just showed you with the mirror, but we're going to do it without a mirror. And more importantly, since we don't all have graph paper, we're going to do this without graph paper. Okay, so to do this without graph paper, what I'm going to do is I'm going to just approximate graph paper by drawing a coordinate plane or a Cartesian plane. Okay, so I'm going to try to keep this straight as possible, right? But again, it's just a visual aid, so it doesn't have to be perfect. Okay, and then I'm going to plot these points. Now, it looks like I'm just going to do a 5 by 5. So what that means is I'm just going to go like this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and again, you can tell mine's not perfect, and yours isn't going to be perfect either. So this is just a visual aid to help us get the coordinates for what we're doing. Okay, and thank you for the email reminder. I appreciate that. I just saw it pop up in my email. All right, so I'm going to plot these points. Now remember, if you have troubles plotting points, right, all points come in an X and a Y. The X tells us left or right, and the Y tells us up and down. Okay, so if you're having trouble plotting points, just always remember they come in pairs. The first one tells you left to right, the second one tells you up and down. So for my A here, I'm going to go left 3, up 2. So I'm going to do this in red. So I'm going to go left 1, 2, 3, and then I'm going to go up 1, 2. And I'm going to do my best. It's hard because I'm not looking straight at this. Okay, so here is my A. And you might even be like, hey, I'm just going to write this down so it's easy to see. So at -3 up 2, there's my A. My B is -1, 1. So here's my B. And then my C is -4. So 1, 2, 3, 4, and then up 1. Now, all our triangles might look a little different because our coordinate systems are all a little different because we're not using the same coordinate, right? Like I'm just guessing what a unit is. Okay, so but remember, our pictures don't need to look the same. We're just using this as a visual aid, right? It's helping us find the coordinates of our new triangle ABC. Okay, so all we did is we put the given down. Now we're going to reflect this over the y-axis. Well, the y-axis is up and down. So what I'm going to do is I'm going to put a blue. Now it's really hard to see, and I apologize about that, but I'm going to put a little blue dashed line up and down, and this is my mirror. Now, in case you guys forgot from Algebra 1, the x-axis is the line x equals 0. So this is the line x equals 0, okay? X equals goes up and down. So just like I had before, right? I'm going to have my mirror on the y-axis, and so I'm going to reflect this over my mirror, okay? Now, to do that, what I'm going to do is I'm going to find the distance from the pre-image to the mirror. So, for example, let's say I start with A. A is, right, if I go like this, A is 3 away from the mirror, right? Because I can count. I can go 1, 2, 3. And that's what the aid is helping us do. It's helping us count. So on the other side, I would go 1, 2, 3. Oops, I'm going to use black here. 1, 2, 3. Like this. And so it's the same distance to the mirror and from the mirror. And then when I go to label this point, this is my new A, so I would call this A prime. Okay, so I have A prime. Now I'm going to do this with my other 2 points. So for B, B is 1 away. So on the other side, I'm going to go 1 away. And then right here is going to be my B prime. Kind of run out of room there, right? I should have zoomed in. Okay. So again, the distance to the mirror is the same as the distance away from the mirror. And then I do the last one, C. So I'm going to have, how far away is that? 1, 2, 3, 4. 1, 2, 3, 4. And then I have, it stays at the same height. So I have C prime. So then I go like this. Now, some of you guys aren't using different colored pens like I am. And so it's really hard sometimes to tell which one's which. Make sure you're labeling it prime. And then some people found success with doing a dashed line shape for the second shape. So that way they can tell between a solid line and a dashed line. So that's kind of a trick that you can use in the future if you're having trouble seeing the difference between the two. All right, cool. That's it. So our aid really helped us. So the last thing we need to do is we need to write down the coordinates of our new shape. So to get the coordinates of our new shape, we're always going to start at 0, 0. So starting at 0, 0, to get to A prime, I'm going to go right 1, 2, 3. And I'm going to go up 1, 2. Okay, and that's it. So then I do the same thing for B prime. I go right 1, I go up 1, so this would be 1, 1. And then C prime, I'm going to go right 1, 2, 3, 4, up 1, so I'm going to be at 4, 1. Woo! Exciting. Okay, so that would be my answer. Okay, so again, this here doesn't have to be super detailed oriented. All we're doing is we're mimicking using graph paper. Okay, so I plotted the original pre-image. I drew in my mirror. I found the distance between my mirror and the image. And then I'm able to create my image. That's it. Okay, well, that's it for doing some basic ones. So what we need to practice then is just a quick review, an example, and then we're gonna keep moving because I don't have a lot of time left. Okay, does anybody have questions about this, about what I did, how I got these answers? Yay. And hey guys, it's okay to have questions, so please, 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 if you have questions, go ahead and ask. All right, so let's go ahead. Now, before I do this, we're going to be doing a lot of graphing stuff. So let's just do a quick review of Algebra 1 graphing. Okay. So let's talk about graphing. So there's two things that we need to talk about. So we're going to be graphing. I don't know why I'm breaking this up word by word. We're going to be graphing vertical and horizontal lines. And I know that I went off there. Okay. So we're going to be graphing vertical and horizontal lines. So vertical means up and down, like that. Okay. So if you're a basketball player, you might often brag about your vertical jump. Okay. So vertical, up and down. And the equation for vertical is always x equals something. Okay. And what that means is that the x stays the same and y changes. Okay, so you can think of this as being like an elevator. The position, the x position in the building, right? Like it's 2 doors to the left is the elevator. That always stays the same. It will always be that location in the building. But what changes is that it goes up and down, right? So vertical, the x is staying the same. Like, so, right, can you imagine you walk into a building, you look at a wall, there's 4 doors. The elevator is always going to be the same door. It's going to be in the same location on the floor. What changes is the up and down, the y. So we say x is equal to something, only the y changes. Horizontal is left to right. Okay. Here, you can think of horizontal being, so you get on the elevator, you get to a floor, and then on that floor, you're at the same height. That floor is the same height everywhere. So you're just going left to right on that floor. Okay. So in here, y is always the same, right? So the floor you're on is always the same. Okay. So the y stays the same. And you can think of it as the floor of a building, and the x changes. Okay, the x changes. Okay, so that's just a little review of doing that. Okay, now so there's my little review. Okay, so what we're going to do now is we're going to practice some reflections. Okay, all right, So what is this? Example 2. So I'm going to give you a triangle. And the triangle is going to have these points. It's going to be, A is going to be 1, 3. So point A is going to be 1, 3. Point B is going to be 5, 2. And C is going to be 2, 1. Now, and I'm just going to remind people, right? Every point comes in an XY pair. X is left to right. Y is up and down. Okay. So we're going to do 2 different problems. So this isn't composition. So I'm not going to say composition. So problem 1, we're going to reflect. And I just really want to emphasize that. This is not a composition. So we're going to reflect triangle ABC over x equals 3. Okay, so we're going to reflect that triangle over x equals 3. Now remember, x equals 3, so x equals, that's going to be a vertical line. Okay, so you see x equals 3, that's going to be a vertical line. And then our second problem is we're going to reflect triangle ABC over y equals 1. Okay, and then you see that y equals 1, that's going to be a horizontal line. Okay, now I did not say composition, so we're not building off each other. If the only time that you build off each other is when it says composition. So these are 2 separate problems using the same coordinates. Okay, so we're going to solve problem 1 first. Okay, so here's problem 1. To do this, I need a visual aid. So I'm going to draw a coordinate system. Okay, it looks like my biggest number I have here is 5. So I'm going to make a 6 by 6. Okay, so I'm going to count 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And again, it doesn't have to be perfect. This is just a visual aid. Okay, so I got my, you're getting your coordinate system down. It shouldn't take a long time because it's just a visual aid. You're going to do the best you can. What I'm going to do now is I'm going to plot my pre-image. Okay, so A is at right 1 up 3. Here, I'm going to try to be over it. Okay, so here's A. B is right 5 up 2. So 1, 2, 3, 4, 5 up 1, 2. So here's B. And then C is at 2, 1, 2, 1. Like this. So if I connect these, I'm going to get my triangle. And again, this is just a visual aid. You can tell my lines aren't very straight. This is just a visual aid. So your triangle is going to look something like that. Okay? And that's my original shape, triangle ABC. So that's the first thing I did. I get a coordinate plane down, and I get my original shape on there. Okay? The next thing I'm going to do is I need to put my mirror in there. Now, my mirror for this case, I'm going to use a dashed line. Okay, so how do we do this? It says x equals 3. So how do you graph lines? Well, 1, you can memorize it, but that's silly because you're just going to forget. And a lot of you probably have forgotten how to graph the line x equals 3. So here's how to do it without memorizing. To draw a line, you need 2 points. Okay, well, x equals 3. Just get 1 point. So if I go right 1, 2, 3, there's 1 point where x equals 3 because that's what x does. It tells me write 3. So here's 1 point where x equals 3. Now, if I want another point, if I went to the right again, that would be x equals 4. That's not true, right? So I can't go to the right. If I go to the left, that's x equals 2. It can't be that. So I can't go right, I can't go left. That means I can only go up or down. So if I go like this, every single point on this line is going to have one thing in common, and that is all of these points are going to have an x of 3. Right? Now the y is going to change, but all of these points are going to have an x of 3. So if this was a building and these were all doors, the third door on the right is the elevator door, and it's going to take me up and down this building. Crazy, right? How many buildings have you guys been in with 6 basement floors? That's crazy. It's like some Marvel level stuff right there. Okay, so now I've done 2 things. I've gotten my original shape and I've gotten my mirror. Now I'm going to find my image. And to do that, this is going to be a little bit different than when we're used to with looking into a mirror. Notice how I have vertices, or I have points on either side of the mirror. It doesn't matter, guys. All that matters is the distance from the original shape to the mirror is the same as the distance from the mirror to your image. So for example, let's say I start with A. So A here is at 1. So I'm going to count over 1, 2. So if I go like this, I get 2. Okay, so on this side, I'm going to go 1, 2. So obviously, you can tell that I didn't draw this very well because this 2 looks a lot bigger than that 2. But there's A prime. That's it. That's all there is to it. And this is why, even without graph paper, you should do it this way. Because you're going to get it right 100% of the time if you do it this way. Takes a little bit more time, but you're going to get it right all the time. Okay? And then we try B. B is how many away? It's 2. So on this side, I'm going to go 1, 2. So right here, I'm going to have B prime. Sorry, I kind of got lost there. So I have B prime here. Okay, so again, the distance was 2 to the mirror. On the other side, the distance is 2. If I look at C here, C has a distance of 1. So on the other side, I'm going to go a distance of 1. So I have C prime. And then if I connect those, you can see my triangle. Now again, if you're just, see how complicated this is starting to look? If you just have one color, make that new shape a dashed line shape. And then you're going to be able to see it a lot more. Now, and I'm also showing all my work. If you didn't show your work, it would be easier to see. Okay? And this is going to be as complex as they get. So I wanted to start out with that. So again, what we want to do here is we want to find the coordinates for all of these. Okay. So I take a look at A prime. A prime is to the right 1, 2, 3, 4, 5. Okay. And it's up how many? 1, 2, 3. Okay. And then I look at B prime. Remember not to do B. So B prime, it looks like it's right 1. And then it's up 1, 2. And remember with coordinates, right, we always go from the origin, from 0, 0. And then for C prime, it looks like I'm going to go right 1, 2, 3, 4. And then I'm going to go up 1. And there's my new points. Okay. I hope you guys are doing okay. I know that this is, it's really different, right? We're drawing pictures, we're doing all this. And our picture's going to look a little different, right? Depending on how big we drew our coordinate system, right? But that is that. Okay. Are we doing okay so far? You guys, are we okay with this before I move on and do the second one over y equals 1? Because I'm running a little low on time. So if you have questions, please ask. But I'm going to start setting up this next one. Because I'm going to do the same thing, right? I'm going to draw a coordinate system. I'm going to make a 6 by 6. Okay, so, oops, I'm not on the screen there. So I just went and did 6 tick marks. You can tell already this looks different than my last one. That's okay. So going on your question, if it's on the right side of the mirror to start with, then it's going to be on the left side of the mirror to end with. If it's on the left side of the mirror to start with, it's going to be on the right side. So it doesn't have to do with positive or negative. It just has to do what side it is. So with the reflection, the image is always going to end up on the other side of a mirror. So think about that. When you look in a mirror, your image is always on the other side of the mirror. So if you looked into a mirror and then you saw your image standing behind you, you would be really freaked out. Why are they on the same side? So if you take a look here, B was on the right of the mirror. So my mirror is blue. So B. So now B prime is on the left of the mirror. A and C, they started out on the left side. So now A prime and C prime are on the right side. Yeah, and that's a good check, right? Because if you were to look in a mirror and your image was standing behind you, that's like scary movie level stuff, right? We don't want that happening. That's like stuff of nightmares. Okay. All right, so what I'm going to do here is I'm going to graph my original shape again. Yeah, and again, that's why I really like stress drawing the mirror as a dashed line, because if you draw this as a solid line, then how do you know where 0, 0 is? Is 0, 0 here or is 0, 0 here? So you have to draw the mirror as a dashed line, or else you're going to lose where your origin is. Okay, so I'm going to graph this again. So looking at this, A is 1, 3. B is 5, 2. So and C is 2, 1. So again, I'm just doing my best, right? So I'm using the same points as we had before. Now this time, my mirror is gonna be y equals 1. Okay. So what I do is I get 1 point. That's y equals 1. So that's up 1. And then I think, okay, what happens if I go up 1? Well, y would equal 2. And what happens if I go down 1? Y would equal 0. So I can't go up or down. So the only thing left to do is to go left and right. Do you guys see how, like, you don't have to have that memorized? You can just guess and check, right? You just have to guess and check here. Another way to think of this, it's all points up 1. So in the past, some of my students have really liked that. It's all points up 1, right? So look at that, right? It's all the points that are up 1. Okay, so they all have in common that they're 1 up, only the x is changing. Okay, so this is my line, y equals 1. So now, cool. So before I get started on this, because I had some great questions from one student saying like, hey, how do we know what side they're going to be on? Notice here, C now is on the mirror, right? And I kind of showed you that with my finger. If you kiss the mirror, you're kissing your image. Because what's the distance from the mirror? The distance is 0. And so if the distance is 0, then the image is also going to be 0 away. So I'm going to go ahead and do this one. So if I'm at A is 1, 2 away from the mirror. So on the bottom, I'm going to go 1, 2. So here is A prime. Right? So I went 1, 2, 1, 2. C is right on there. So I'm just going to put a red dot and say, hey, there's C prime. Maybe that's going to get in the way. Here, there's C prime, right? Right there. Okay, and then B is 1 away. So on the other side, I'm going to go 1 away. And if I connect that, you guys can see the reflection, right? Can you see like it just flips over like that? Now, the red one looks a little bit bigger because my coordinate system isn't great, but you get the idea. And what it allows us to do, it allows us to find the coordinates. So A is to the right 1, down 1. B prime is 1, 2, 3, 4, 5 to the right, up or down, nothing. And again, make sure you make this a dashed line or else you're going to think this is 0, 0, and that's confusing. So, and then C prime, well, C prime is the same as C. It didn't move. Okay, it's going to be like that. Holy moly. When do we get out of class? Are we out at 11 or 11:10? I always forget. I can never remember. I don't know why I can't remember that. We're out at 11. Oh my gosh. So I really need to get going because we only have 10 minutes and I have stuff that we need to talk about. Okay, so this is an example. Both of these guys are examples of using an image to help us get the coordinates for our reflection. So you draw your original shape, you draw the mirror, and remember the mirror is going to be hard for some of you guys because we've forgotten how to graph. So we're going to draw the mirror, and then we're going to find the distance to the mirror and do the same distance away from the mirror. Okay, that's the key here. All right, so The problem is that those can easily be done with just a sketch of a coordinate system. But some reflections are more complicated. Now, if we were in class, we would just do all of this on graph paper. I'd give you all graph paper, and you guys would be fine. We could just do everything on graph paper. You would never have an issue. But since we're not in class, unfortunately, we don't all have graph paper. So I'm going to have to teach you guys formulas. But the good thing is, we don't have to memorize anything this year. So I'm going to give you formulas. Everything we do is open note. Just have the formulas out with you to do them. Now, I say that, so you're like, well, Kreft, if you just gave us formulas, why did we do all of this? Because these don't have formulas. So I'm only giving you things where there is formulas. Okay, so you're not going to be able to use a formula for anything. So the ones that are easy to draw like this, you can't use a formula. And I'll show you which ones you have to use a formula for. So here's the formulas. We have coordinate rules for reflections. So make sure this is in your notes because, right, everything is open notes and you can have this and it's going to make certain problems that we can't do without graph paper possible. Okay? So now there's 4 of these. The first 2 are shortcuts. You don't need to know these first 2. Okay? So you can even add that in your notes. Hey, these first 2, they're just shortcuts. Okay? So if you have some point A, B. Okay? So when I say A, B, A and B are some numbers. Okay? And if it is reflected over the y-axis, right? We did one of these, right? So remember, this is a shortcut. You can draw this one. Okay, so again, this is a shortcut. Okay. Then the A becomes, oops. Sorry, I'm going to restart. Then you have A negative B. So basically all you're doing is you're changing the sign of the y term. Now, I'm going to warn you, that only works for the y-axis, right? That doesn't work if I have x equals 3, or if I have x equals 7, or x equals 8. So again, this top one isn't very useful. It's a waste of time to memorize. Okay, I'm just going to say it. This is a waste of time to memorize because you can just sketch this really quickly and get it without memorizing it. Okay. Next up. Okay, so I just really want to stress, I'm telling you these, but they are a waste of time to remember. The only reason I'm telling you these is because everything is open notes. So if you have a point AB and it is reflected over the x-axis, so everything the same, but now it's the x-axis, then the x changes sign and the b stays the same. And don't worry, we're going to practice this just a second. Okay. Again, you can write these 2 down. I don't like using these because if you use them, it's really easy to mix up which one's negative. Okay? Whereas if you draw the picture and you count, it's a lot harder to mess up counting. Okay? So they're here, they exist. I don't recommend using them. Now, these next ones you have to use. Okay? So if we're going to, so these are for diagonal lines. Unfortunately, for diagonal lines, unless you're really good at this, you need graph paper. Okay? And we don't have graph paper. So for diagonal lines, these next 2, you're going to want to use these. Okay? So here they are. If you have a point AB and it is reflected over y equals x. Okay, so if you have a point AB and it is reflected over y equals x. Now, if you don't remember what y equals x looks like, I'm just going to draw a quick picture here. Y equals x looks something like this. Now, I'm really sorry, guys. I only have 3 minutes left. What the reflection over what? You're like, why are we doing this reflection if it's like we need graph paper for it? This reflection is the single most important reflection out of all the reflections. Okay? Hands down. This is it. This is the important reflection. I can't talk about it more, but this is the most important reflection. You're going to be using it in Algebra 2, in Pre-Calc, and beyond. Okay? It has to do with inverse functions. Okay, so the solution to this is BA. Now, this should make sense, guys, because what's happening is literally x equals y. So my new x is literally my y. And also y equals x. So my new y is my old x. So it literally means switch that x and y are equal, and you're just switching them. Okay, it's like the converse of reflections. Okay, the other one that you're going to need is if you have a point AB and it is reflected over, and it's just y equals negative x. And hey guys, if you can remember this top one, this bottom is really easy. You're going to switch and add in a negative. It's like the contrapositive of reflections. Okay. These are formulas that you have to use. Okay, so if you're reflecting over y equals x and y equals negative x, you have to use these. Without graph paper. Okay, so, oh my gosh, I only have like 3 minutes. Okay, with my 3 minutes left, I want to practice using these. 50 minutes really isn't a lot of time, and think about it. I start a warm-up 5 minutes before class starts, so 55 minutes isn't even enough time. So I have EX, example. Okay, so let's say we're going to do a segment to make it quick. Okay, so I have segment AB, and A is -1, 3, and B is 2, -2. I'm just making up numbers. So get that down. So we're going to do 3 reflections. We're going to reflect segment AB over y equals x. This is not composite, so they're not building on each other. We're going to reflect segment AB over y equals -x. And just because we can, we're going to reflect segment AB over the x-axis. Okay, so and this is just to show you how the formulas work. Okay. Sorry, I know that was a lot to write down, so I'm just giving you guys a little second to get it all down. I apologize if I'm going too fast. It's just I want to respect your time, and I also want to get everything you need to know. So y equals x. I'm going to look at the formula. So y equals x, it can be summed up like this. I'm going to take my point, every point AB, such that the B and the A are going to switch. Do you guys see that? So here's kind of like a shorthand of the formula. I'm going to take every point AB such that B and A switch. So when I go to write my A prime, right? When I go to write my A prime, I'm going to take my X and Y's and I'm going to switch them. So A prime would be 3, -1. And then B prime is going to be -2, 2. Now notice, now you guys are like, oh my gosh, why don't I always use formulas? There's no formulas for these ones that we just did. Now, you're right. Some of you are like, well, I'm going to make a formula. You absolutely could. It's a waste of time because you're going to have to make a new formula every time. And unless you're doing a million of these, it's not worth it. It really isn't worth it. Okay? All right. So that's how you do that. And if you guys have questions, let me know. Now for this next one, the formula here is I'm going to take every point AB
such that I get negative b and negative a. Now you can think of the negatives as saying change the sign. Okay, so if it was negative, it becomes positive. If it's positive, it becomes negative. So I'm going to have a prime here is I would switch them and change the sign. So I'm going to switch, but now it's going to be negative 3 and positive 1. And then I'm going to have b prime would be positive 2 and negative 2. So I switch them and I change the sign, which is funny because b and b prime are actually the same thing. Kind of cool, right? Because this point, right, is on that line. Okay. And then this last one, right, my formula here is I'm going to have all my points A, B such that, and it's the x-axis, so I'm going to have negative A, B. And I'm not going to lie to you guys, I don't have this one memorized. I literally had to look at my notes. I'm a teacher, and I've taught this for this is my 13th year. Never memorized this. Okay, so I'm going to have A prime. So I'm going to switch that. No, I'm just going to make the first one opposite sign. So 1, 3. And then I have B prime. I'm going to have negative 2, negative 2. Okay. So